In this section, our goal is to be able to solve quadratic equations algebraically using the quadratic formula. Let's begin by reminding ourselves, what is a quadratic equation? That's an equation that can be written in the standard form ax squared plus bx plus c equals 0. One way to solve a quadratic equation is by using the quadratic formula. That's a formula that can be used to solve a quadratic equation. Here is the formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Notice the letters a, b, and c are used in this quadratic formula, and we showed the coefficients a, b, and c in the quadratic equation. So in order to use the quadratic formula, it is important that we write the quadratic equation first in standard form. Let's try some examples. Solve each quadratic equation using the quadratic formula. Remember, when it says solve, we're looking for what x equals. Number 1, 3x squared minus 5x minus 2 equals 0. First of all, I want to make sure that my quadratic equation is in standard form. That's the first thing to look for. The x squared is first, then the x, then the constant, and then equals 0. I see that I have that, so now I can move on to the next step, which is identifying what is the a, the b, and the c of the quadratic equation. Next to the x squared, multiplied to it, is the a. In this quadratic equation, that's 3. Multiplied, or the coefficient of the x term, is the b. That's negative 5. So b is negative 5. And the c is the constant added after the x term. That's negative 2. Now we go to use the quadratic formula. Notice this part under the radical is very complicated, so we'll do that part first. That's called the discriminant. So b squared minus 4ac is first. b is negative 5. Negative 5 squared minus 4 times a, which is 3, times c, which is negative 2. Negative 5 squared makes positive 25. And we see a negative times a negative, so we're going to write plus 4 times 3 for 12, and 12 times 2 for 24. Add that together, and we get 49. So now we'll go to our quadratic formula, and it's easier to plug things in. X equals, the opposite of b comes first. Well, b is negative 5, so I'm going to write negative of negative 5, or I could just write positive 5 because that means the opposite of b. Plus or minus the square root of all the stuff I did earlier, so the square root of 49. All divided by, notice just the stuff over here, not the equal sign, all divided by 2 times a. 2 times 3. Let's simplify this a little bit. So x equals negative of negative 5, or the opposite of negative 5, is positive 5, plus or minus the square root of 49 is 7. All divided by 2 times 3 makes 6. Now notice this says plus or minus. That means we do both. So from here, I'm going to branch off to show that x either equals 5 plus 7 divided by 6, and x can equal 5 minus 7 divided by 6. So here we get x equals 12 divided by 6, so x equals 2. And here we get 5 minus 7, so x equals negative 2 divided by 6, which is negative 1/3. So we can write our solution set as 2 and negative 1/3. Remember that quadratic equations will commonly have two solutions because they're of a degree of 2. Let's try another one. Number 2, 4n squared plus 12n equals negative 9. The first thing we notice, it doesn't say equals 0. It's not in standard form. So let's add 9 to both sides and rewrite this in standard form. 4n squared plus 12n plus 9 equals 0. And now I've got standard form. Next, identify A, B, and C. A is 4, B positive 12, and C positive 9. Now, it's helpful to memorize the quadratic formula, and the more we write it, the more we'll remember it. So let's write it again. Now, because our variable is n this time, we can write n equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. Remember the part that we want to do first? The discriminant. Let's do the discriminant first. B squared minus 4ac. B is 12. 12 squared minus 4 times a is 4 times c is 9. 12 squared is 144. And 4 times 9 makes 144 as well, so our discriminant is 0. Now let's go plug that in to our quadratic formula. N equals the opposite of b. b is 12, so negative 12, plus or minus the square root of the discriminant, which is 0, and then all divided by 2 times a, which is 4. And now let's simplify. N equals negative 12 plus or minus the square root of 0 is 0. All divided by 2 times 4 makes 8. Now here's where we normally would branch off, but whether I add or subtract 0, it does not change negative 12. So I only have one possible answer, negative 12 divided by 8, or simplifying that, negative 3/2. So my only solution for this problem is negative 3/2. So remember, usually a quadratic equation will have two solutions, but when the discriminant is 0, we're going to get one solution. One more, number 3, x squared plus 3x minus 9 equals 0. I see that it's in standard form because it's equal to 0 and it's x squared, x, and then a constant. So let's begin by identifying A, B, and C. In front of the x squared, the coefficient is 1, so A is 1. Multiplied to the x, the coefficient is 3, and the constant is negative 9. Now let's do the discriminant. But let's practice writing our quadratic formula first. X equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. The discriminant is that part under the radical. B squared minus 4ac. b squared is 3 squared minus 4 times a times c. 3 squared is 9. Negative times a negative makes plus. 4 times 1 is 4 times 9 is 36. Adding those makes 45. Now let's go plug it into our quadratic formula. X equals the opposite of b. b is 3, so that's negative 3. Plus or minus the square root of the discriminant is 45. All divided by 2 times a, and a is 1. Let's simplify. X equals negative 3 plus or minus. Now, 45 is not a perfect square, but remember, we've learned how to simplify radicals. So perhaps off to the side, we'll remind ourselves how to simplify the square root of 45. Well, I know there's a perfect square in 45. The biggest one that divides into it is 9. I can write the square root of 45 as the square root of 9 times the square root of 5. The square root of 9 is 3, so 3 square roots of 5 is how to simplify square root of 45. Let's go ahead and put that back in that spot. And then all divided by 2 times 1 is 2. And here's where we would branch off. X can equal negative 3 plus 3 square roots of 5 divided by 2. X can also equal negative 3 minus 3 square roots of 5 divided by 2. However, this is a radical. This is not a radical. Those are not like terms. I cannot add them or subtract them. So unless I can simplify further with a common factor in the numerator and denominator, I will stop here. So my solution set could either look like negative 3 plus 3 square roots of 5 divided by 2, comma, negative 3 minus 3 square roots of 5 divided by 2. Or I could write it simpler as negative 3 plus or minus 3 square roots of 5 divided by 2. Either way, it shows that I have two solutions for my quadratic equation. Take a couple of minutes to write yourself a short summary and think about what we've done. What is the difference between a quadratic equation and the quadratic formula? See you in class.